We have 9 characters, which include 4 letters, 3 numbers, and 2 symbols, and we need to create a password with 6 characters. Here, the order of the characters matters because swapping 2 characters creates a completely different password. Therefore, we use permutation, which is a method to count arrangements where the order is important. The formula for permutation is written as NPR, where N is the total number of items, and R is the number of items we select and arrange. In this case, N is 9, since we have 9 characters, and R is 6, because the password is 6 characters long. 9p6 means 9 factorial divided by 9 minus 6 factorial. The calculation gives 60,480. Thus, there are 60,480 different passwords possible without restrictions. Now, the password must consist of 2 letters, then 2 numbers, and finally 2 symbols in specific order. Since the order is already defined, each section needs to be arranged independently. We have 4 letters to choose from A, B, E, and F. To arrange 2 letters, we use 4p2, which calculates the number of ways to arrange 2 items from a group of 4. The calculation gives 12. Next, we have 3 numbers, 5, 8, and 9. Arranging 2 numbers from this group involves 3p2, which gives 6. Since there are only 2 symbols, arranging both involves 2p2, which equals 2. Now, we multiply the arrangements for letters, numbers, and symbols because these are independent choices. 12 times 6 times 2 is 144. So, there are 144 valid passwords with this restriction. Now, the password starts and ends with symbols. The first and last characters must be symbols, leaving 4 positions to be filled with letters or numbers. There are 2 symbols, and both must be used in a specific order. So, the number of ways to arrange them is 2p2. After using the symbols, we are left with 7 characters. We need to arrange 4 characters, and the order matters. Thus, we use 7p4. Multiplying gives 1,680. In Part B, the candidate must answer 6 short questions from Section A and 3 long questions from Section B. Since the order of answering the questions does not matter, we use combinations to calculate the number of ways to select the questions. The formula for combinations is written as N choose R, where N is the total number of items and R is the number of items we select. Selecting 6 short questions from Section A can be calculated as 10 choose 6, which is equivalent to the fraction, where the numerator is 10 times 9 times 8 times 7, and the denominator is 1 times 2 times 3 times 4th. So, there are 210 combinations. Selecting 3 long questions from Section B is 5 choose 3, and the calculation gives 10. Since the selections from Section A and Section B are independent, multiply the results. Thus, there are 2,100 different selections of questions possible. Now, the first 2 questions in Section A and the first question in Section B are fixed. This reduces the number of questions we need to choose. From Section A, only 4 more questions need to be selected from the remaining 8 questions. The number of combinations is 8 choose 4, which gives 70. From Section B, only 2 more questions need to be selected from the remaining 4 questions. The number of combinations is 4 choose 2, which gives 6. Since the choices are independent, we multiply the results and the answer is 420. Thus, there are 420 different selections of questions.